We're looking for the partial sum of this expression from n equals 4 to infinity. And all we have right now is we can use what's called telescoping. But in order to use telescoping, you have to get the partial sum. So in order to get the partial sum, and I'm just going to worry about this situation. And that is equal to 5 over n squared minus 4n plus 3. So I need to make the partial sum an minus 3a plus bn minus b equals 5. You might recall that the denominators are going to cancel out in this process. And then we're going to go ahead and derive a system from this where it's going to be a plus b is 0, negative 3a minus b is 5. That'll lead to negative 2a is 5. A is negative 5 halves. B is 5 halves. So this summation would be rewritten as, oh, there's a lot of ways you could write it. I'm going to go ahead and rewrite it as negative 5 halves factored out of a summation of 1 over n minus 1. Now, because I factored out a negative, the second expression is going to be a negative. So I'm going to have to figure out the summation of 1 over n minus 1, subtract the summation of 1 over n minus 3, and I'm going to multiply the result by negative 5 halves. And we're going to show out of all this craziness, we're going to have a convergent sum. So in order to move forward, let's really break this down. Wait a minute. Okay, so there was a little technical difficulty. So I'm going to have a situation where I have negative 5 halves times this summation. Now I'm converting to I, but don't let that upset you too much. We're looking to arrive at an infinite limit. So this is what's going to happen. Now, based on telescoping principles, the first terms are going to be 1/3 minus 1. Actually, you know what? It just occurred to me. I don't like this in the wrong order. I'm going to go ahead and reverse the process. I'm going to go ahead and turn everything into a positive. I'm going to make it 5 halves times the summation. So I probably should have just factored out 5 halves. It's just going to flip the difference is what it's going to do. Okay, so once I get to that, I just know once I start breaking out actual values, I'm going to get a 1. I'm going to get a 1/3. And then I'm going to get a 1/2 minus a 1/4. And then I'm going to get a plus a 1/3 minus a 1/5. And then this process is going to continue. Next thing you know, I'm going to get a 1/n, and I'm going to subtract a 1/n minus 2. But here's what should happen in this process. Now the 1's going to stay, the 1/2's going to stay, but the 1/3 is going to cancel out. The 1/4 will have a 1/4 to cancel out. Ultimately, the 1/5 will also have something to cancel out. And this process is going to continue all the way down until you get to these last 2 expressions. The answer to that is going to be 5 halves times 3 halves. Because what's going to happen is, keep in mind, n is going toward infinity. And if n is going toward infinity, that expression is going to 0. That's going to be the only expression left. So we don't have to worry about that expression anymore for some way out sum out there. But you can conclude that all of the other values cancel out, and you're going to get left with 3 halves. And the answer to that is going to be 15/4. And that would be your final answer. Just another thought process here. It was 1 minus a 1/3, 1/2 minus a 1/4, 1/3 minus a 1/5, 1/4 minus a 1/6, 1/n. Now, actually, upon further review, I'm realizing that I think I'm actually going to still be left with 1/n minus plus 1, 2. But that's another situation that's going to go to 0 as n goes to infinity. So I'm not even going to worry about those terms. All I have to worry about is 5 halves times 1 plus 1/2. And that would be the telescoping sum of that partial sum sequence.